Alright, kiddos, so we're going to do a video on the other part of quadratic functions whenever you analyze it. And we're going to look at some more situations that have graphs, and we're supposed to talk about the vertexes, the vertices, and the x-intercepts and things like that. So, I've got my calculator out. I don't know that we'll necessarily need it, but here's what your note sheet looks like, and let's take a look at it. So question number 1 says that a stone is dropped from a height of 500 feet above the ground. The graph shows the stone's distance from the ground at different times. Which of the following is a correct interpretation of the graph? So a correct interpretation. Alright. Well, we do need to understand that the y-axis is in height. The x-axis is in time. And so let's go through these and see which one fits and which one doesn't. Letter A says that the stone lands about 5 feet from where it was dropped. Well, remember that this is the path of the quadratic. It is not the path of the stone itself. If I were to drop a stone, it just falls straight down. It doesn't take this path over 5 feet. And in fact, this 5 right here is not even feet. It's time in seconds. All right, so be sure that you understand what we're looking at on the graph. The graph is a picture of the path of the stone as it falls. Again, I just talked about that. If I drop a stone from this point, it's going to drop straight down. This is not the path of the stone. This is the path of the quadratic. Letter C says the stone hits the ground between 5 seconds and 6 seconds after it's dropped. Well, here's where it's dropped. Here's time passing, and sure enough, it does hit the ground in between 5 and 6. That's the one that we want. Alrighty? So, let's move on to question number 2. Question number 2 this time shows a table. Alright, let's get this a little bit bigger so we can see everything about it. Alright, now, we've been looking for, we've been looking at graphs instead of tables. Well, now that I give you a table, we need to be able to talk about how to find vertices, how to find x-intercepts, zeros, roots, and all those things. That's what this question is testing us on. It says the table below shows selected values of a quadratic function. Based on the information in the table, between which two integers can one of the zeros of this function be found? Remember, zeros are roots, zeros are x-intercepts. And if it's an x-intercept, then that's where y equals 0. So let's look at the y values. All your y values are stuff other than zeros. But remember, this is just selected values of your quadratic. Okay? Well, in between what values on the y would we find a 0? In between 21 and 7? No. In between 7 and negative 1? Yeah, you sure would. There's a 0 right in between there. Alright? Well, right in between there corresponds to right in between there for the x values. Remember, the x-intercepts are the x values where y is 0. So whatever x values are in between those, that's going to be a possible 0. But that's not the only place. If you look closer towards your, down your table here, in between negative 1 and negative 3, that's not a 0. But if I go from negative 3 to positive 1, I'm going to pass another 0. Well, there's another 0 right here. Okay? In between these two x values. And sure enough, our answer choices are between 3 and negative 2, 2 and negative 1, negative 1 and 0, and 1 and 2. These are x values. Alright? And we've looked here that in between these two y values there's a 0. So I'm going to find the x value in between negative 2 and negative 1 and 0 and 1. So in between negative 2 and negative 1 is going to be, I think this one should be a negative 2. Okay? Because in between negative 2 and negative 1 there is a 0. So that's going to be my answer choice. Question number 3. If you flip this note sheet over on the other side, you're going to find question number 3, and that's going to be all for our notes today on this one. Question number 3, again, we're dealing with real life situation. It says the community service club at school sells hamburgers at football games to raise money. The club has tried different selling prices for the burgers to see how the different prices affect its profit. The graph below shows the total profit the club expects to earn during depending on the price it charges for the burgers. At what amount should the club sell the hamburgers in order to maximize its profit? Highlight, underline, maximize. All right? That's going to be talking about the maximum point on our graph. Well, that's going to be right here. All right? That's going to be the total profit on the y-axis and the selling price right there. Well, we're looking for the selling price, right? How much should we sell the hamburgers for to get the maximum effort? Well, this point right here on the x-axis for the price is right in between 3 and 4. Well, if it's right smack dab in the middle, that's going to be 3.5. All right? Now, we're talking about money, right? So $3.50. We need to put that into our griddable. Now remember, on your griddable, you can't put a number sign or a dollar sign or anything like that. You can just put the decimals. So we have a positive $3.50. You could put the 0 if you want to. You don't have to. Be sure to color in the colors. There's a decimal point. There's a 5. And there's a 0. All right. So there's a video on quadratics. We'll see you in class.